You're listening to DTFHN from March 27, 2026. I'm your cache-invalidated host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where bad defaults get documented in the comments. Today is a day when craft earns its place and friction earns its explanation. Pull the thread. The devil's advocate case writes itself. Configuration files are a trap. Every hour you spend tuning a claude.md is an hour you're not building. You're writing documentation for a system that changes every few months anyway, and you're baking in assumptions that will be wrong by the next model release. Just prompt better. Treat the tool like a tool and stop trying to engineer the engineering assistant. That argument sounds reasonable. It's wrong, but it sounds reasonable. Here's where it fails. The claude.md file is not documentation for Claude. It's documentation for your team. The AI is just the enforcement mechanism. When you write never expose stack traces to the client, or use the custom logger, not console.log, you're capturing architectural decisions that live in someone's head right now. A senior engineer who left 6 months ago. A code review that happened once and never got written down. The claude.md forces that knowledge out of people's heads and into the repository. The AI following it is almost secondary. The second failure in the devil's case is the assumption that prompt better scales. It doesn't. One developer with a good mental model of the codebase can compensate for the absence of written context. 12 developers, some junior, some new, some contractor. They cannot. The Claude folder is version control team knowledge. That's not a crutch. That's how engineering organizations actually function. Now, the honest criticism buried in the H end. Comments deserves attention. One commenter notes that whatever you write in claude.md, Claude will follow, is doing a lot of heavy lifting. In practice, it's a strong suggestion, not a contract. A complex tasks, long sessions, context, compaction. All of these dilute instruction adherence. If your team is treating claude.md as an infallible rulebook, they're building on a fragile assumption. The right mental model. Claude.md raises the floor. It does not guarantee the ceiling. It prevents the obvious mistakes, services the non-obvious constraints, and gives the model a fighting chance at understanding your codebase before it touches anything. That's worth the 20 minutes it takes to write it. The global versus project-level distinction matters too. Personal preferences in Pogmas how-I'd, do Claude, team conventions in the project root, subdirectory overrides for specific modules. That layered architecture is genuinely thoughtful. It mirrors how real engineering organizations handle configuration. Local overrides, shared default, committed policy. The tools exist. The knowledge is available. Write it down. What if that same documentation habit applies to your home lab? Okay, like finally getting TLS on the brother printer sitting in the corner. When did the printer become a web server? Not metaphorically. Actually, the device that jams on cardstock, that beeps at you at 11 p.m. because it's low on cyan, now has a web interface, an IP address, and, if you follow this guide, a valid TLS certificate signed by a trusted certificate authority, automatically renewed via Certbot and Cloudflare DNS. Pause on that for a moment. In tone some annoying, like sold on thing fied by 4 zopars. And then a cape launched with a specific thesis, HTTPS. Adoption was stalled because getting a certificate was expensive, manual, and slow. Very being wanted hundreds of dollars a year. You filled out forms, you waited, The result was a web where security was a premium feature, locked behind a paywall and a bureaucratic process that small operators simply skipped. Let's Encrypt automated all of it, made it free, and within 3 years, HTTPS went from roughly 40% of page loads to over 80%. One project, one architectural decision, and the entire posture of the web shifted. What this person did is that logic applied to the last mile. The brother printer has a web UI. It does, most do. It has a certificate management page buried in the admin panel, and the way they got Certbot to talk to it? Screen scraping. The script pulls the CSRF token from the admin interface and submits the cert upload form like a human would, just faster and on a cron job. It is objectively a beautiful hack. The printer never anticipated this. It was designed to sit on a LAN, maybe accessible from a browser on the same subnet. Definitely not treated as a first-class HTTPS endpoint. And yet, here we are. The comments thread is a small joy. Someone did the same for Real-Link cameras and Macrotic devices. Someone else built a Kubernetes controller to pick up certs automatically. The pattern is spreading. Every device with a web interface is getting drafted into the modern PKI, whether it was designed for that or not. The tools exist, the knowledge is available, and increasingly the community just refuses to accept that your printer's Self-Signed certificate warning is a permanent condition of the universe. Run this forward and the implied destination is interesting. A network where every device, from your NAS to your camera to your printer, participates in actual cryptographic trust. Not because a vendor decided to ship it that way, because someone screen scraped a CSRF token and wrote it up. Now, story 3. From cryptographic trust networks to the equally serious engineering challenge of keeping a cat off your keyboard. The first comment lands within minutes. Cats can flawlessly detect when something was made for them and then will not deign to use it. The second, I can foresee a design flaw. The cat will ignore all the specially designated areas and sit on your keyboard instead. These aren't cynical takes. They're field reports from people who have run the experiment. Urban planners have a concept called desire paths. Those worn dirt trails that appear through grass where people actually want to walk, cutting diagonals across the pristine geometry of the designed landscape. You can lay expensive pavers in perfect logical grids, but pedestrians will find the shortest line between 2 points and press it into the earth through sheer repetition. The good planners eventually gave up fighting this. Some of them now leave patches of grass unseeded on purpose. Wait to see where the desire paths emerge, and only then pour the concrete. BB Lab, it seems, has attempted to be a good planner. The Neko House desk is a genuine attempt to read the desire paths of a different species. 2-tier lounging shelves along the right side. A cave space carved into the underside of the desk surface, positioned so you won't kick it but close enough for the cat to migrate onto your lap. Cable management slots so the actual work infrastructure stays clean. And this is the one that gets me. The surprise cat hole, a portal punched through the desk surface itself, so your cat can emerge from below like a furry periscope and demand a head scratch mid-meeting. The engineering here is sincere. Someone modeled actual traffic flow. Cat traffic, human traffic, the natural collision points. And designed around the friction. That's craft. That's the kind of thinking that happens when you take the problem seriously instead of treating the animal as an intrusion to be managed. Whether it works is a different question. The commenters are betting on the keyboard. The forgotten cardboard box will remain the premier napping venue. Desire paths form where they form. But Biblab didn't design around the cat. They designed with it. The desk acknowledges that you are not the senior architect of your own home office, and it proceeds from that honesty. Most design pretends the inconvenient user doesn't exist. This one counts them. Designing around the inconvenient user, PARS turns out that principle scales beautifully, even when the inconvenient user is a federal bureaucracy. The word is still. Are you still disabled? Buried in bureaucratic boilerplate but load-bearing. Still. As though disability arrives, and then, given sufficient motivation, departs. As though the optic nerves of a man, blind since birth, might have reconsidered their position. The word reveals the foundational assumption of the system that generated the letter. It was built by people who believe the condition under review is aberrant, temporary, exceptional, something that resolves. From that assumption, everything downstream follows. The phone tree, the flat voice, the insistence on facts. A technology whose primary security property is that it requires physical presence and costs money per page. The Friday deadline. The entire apparatus is calibrated for friction, not verification. Strip it to first principles. What does a disability review actually need to accomplish? Confirm that the condition still applies. For congenital blindness, that verification has a duration. Lifetime. The files exist. The diagnosis exists. The history spans decades. Every piece of required evidence is already in the system that generated the letter. The actual constraint isn't information, it's incentive structure. A bureaucracy that processes fewer claims costs less to run. Friction is a feature. Every person who misses the Friday deadline, who can't reach a library, who doesn't know what an internet fax service is. That's a case that closes. The system isn't broken. It's working as tuned. She gave him a fax number. That was the error. 512 pages, single-spaced. Birth records. Surgical notes. Intake forms from every specialist who ever cataloged his deficits. A word that appears in clinical documentation with startling frequency. Compiled, organized, and uploaded to a service that converts digital data into physical paper at the receiving end. $20 on his side. Paper, toner, and time on hers. The internet solved the friction problem. It didn't eliminate the friction. It redirected it. The comments want to relitigate whether Karen deserved this. That's the wrong question. The right question is who designed a system where Karen has no alternative to offer, where the most efficient path available to both parties is a 512-page fax, where a man born blind must spend an afternoon and $20 proving he cannot see. That system has an architect. The architect is not Karen. What if the tools we use every day were just a pause faster? Story 5, a faster alternative to JQ. There's a moment in 1174 where you can watch the future get locked in. Brian Kernighan ships AUK, and it works, and people use it, and 20 years later, it's still everywhere. Not because it's the best tool for the job, but because it was there first, and it was good enough and everything else got built on top of it. JQ is AUK for JSON. It works. Nobody can remember how it works without looking it up, but it works. The first comment on this thread says it plainly. JQ's syntax is so arcane, I can never remember it and always need to look up how to get a value from simple JSON. That comment has 40 votes. Not 40 votes for same, 40 votes for yes. This is the shared condition of our entire profession. Run this forward 5 years. Every pipeline touching JSON, And that's most pipelines. Runs GQ queries that someone wrote once, in a README that nobody fully understands, that nobody changes because what if it breaks? Configuration as archaeology. The syntax half remembered, half cargo culted, spread across shell scripts that have outlived the people who wrote them. Micah Capey looked at this situation and thought, what if we went back to first principles? The insight is clean. JSON documents are trees. Querying them is describing paths through that tree. Paths can be expressed as a regular language. Regular languages compile to deterministic, finite automata. DFAs process input in a single pass. Obey symbol, no backtracking, no exponential blowup on pathological queries. You pay the query cost once at compile time. After that, search is essentially free. The benchmarks show it against JQ, against Jack, against Gron. JSON rep holds up, and the query syntax is legible on first encounter. Dot paths, wildcards, alternation with a pipe, recursive descent with a clean star. You've seen this shape before. It's not an invented language. It's the grammar you already carry around in your head from every other pattern-matching tool you've ever touched. The comments want to debate whether nanosecond differences matter in practice. That's a fine debate, but it's not the one worth having. The one worth having is why it took this long for someone to apply 50 years of automata theory to the tool we use to interrogate every API on the internet. The knowledge was there. The language. Rust was there. The prior art, with a grep showing exactly how this is done, was there. Someone just had to sit down and build it. Someone just sat down and built something. Story 6 is about someone who decided to leave before the building starts feeling like the whole party. 6 years. One app idea, carried around for 6 years, never built. Then Claude Code turns up, and in 2 weeks, she has auth flows, layout components, a light-dark, system-themed toggle, color palettes derived from her existing logo. The idea is finally moving, and then she quits. Not because it didn't work, because it worked too well. Lara Agmiller is a developer, a full-time mom with very little time, and a project she's been carrying since before the AI hype had a name. She installed Claude Code, got genuinely impressive results, and then looked at the CSS. Here's what she noticed. Redundant declarations inside a single rule block. Responsive breakpoints that weren't quite right. Code that compiles. Code that ships. Code that a senior developer looks at and thinks, this is not elegant. The model can't see the output. It doesn't know what it feels like to resize a browser window and watch a layout fracture in exactly the subtle way that reveals the system didn't understand the visual intention. It's optimizing for plausible syntax. Spatial reasoning, the kind you build over years of staring at rendered HTML. That's a different muscle entirely. That's not a vibe. That's a specific technical observation about what the model is actually doing. And then there's the other thing she noticed. The itch. The pull toward the next prompt. The guilty conscience. Like cheating. Her words. One commenter puts it plainly. A program is not the only output of programming. The other output, arguably the more important one. This is the programmer. This is where bootstrapism gets genuinely complicated. The tools are real. The scaffold is real. A full-time mom with 6 years of deferred ambition can ship auth flows in a weekend. That's the ladder extended further down than it's ever reached. But if the ladder also slowly atrophies your ability to climb, if the tool handles enough of the detail that the mental model never fully forms, then what exactly got distributed? She made the call that her own development as a craftsperson is worth the slower pace, That's a legitimate choice. The tools will be there when she wants them. Craft only compounds if you do the work. Both things can be true at once. The best tools make that choice visible. This one did. That's the kind of story that earns a pivot to pure craft. Story 7 is about logarithms and images. And the 7, yeah, this is exactly the kind of thing we're here for. There's a design decision I keep coming back to from early signal processing work. When you're mapping sensor data, audio levels, light intensity, pressure readings, your first instinct is linear, equal steps, tidy, and it consistently fails because the world isn't linear. Human perception isn't linear. Dynamic range is enormous, and a linear axis compresses everything interesting into a corner. The fix is almost always the same. Take the log. The moment you do, structure appears that was invisible before. At memory surfaced immediately watching this video on taking the logarithm of an image. The mathematical operation itself is simple. Apply logged to each pixel value or to the complex representation of the image. What emerges is something else entirely. Geometric transformations that would require elaborate construction in Cartesian space become simple translations and rotations in log space. Escher's impossible architecture. The spiraling staircases, the recursive lizards, aren't artistic tricks. They're conformal maps. They're what mathematics looks like when you change the coordinate system. One commenter noted this connects to conformal maps in the complex plane, and that 3D space has analogous techniques. Another is already wondering about the Drost effect. The recursive laughing cow packaging, a cow wearing earrings, each of which depicts the same cow. And whether the log transform could generate or analyze that kind of self-referential image. Someone else asked what a game world would look like rendered this way. These aren't idle questions. They're the right questions. Here's the one nobody is asking directly. What else are we failing to see because we defaulted to the wrong coordinate system? This isn't abstract. Every time a dataset gets plotted on a linear axis when it spans orders of magnitude, information disappears. Every time a model is built with Euclidean assumptions on data that lives on a manifold, performance degrades. The log transform isn't just a mathematical curiosity applied to images. It's a reminder that representation choices are load-bearing. The frame you choose determines what's visible and what isn't. The video is described by commenters as a tour de force of communicating a complex concept. The tracks. The rendering pipeline alone. Python with custom OpenGL shaders handling geometric transformations is its own story. Tools built to make mathematics visible, released so others can use them. The question hangs. How many insights are we sitting on top of because we never asked what the space looks like from a different basis? Moving on. Every grain of sand on a beach has a biography. Most of us walk across millions of them every summer without once wondering where they came from. Magnified Zand.com is a straightforward premise. Collect sand from beaches around the world. Photograph it under a microscope. Post the images. That's the complete product. And what it reveals is genuinely startling. Here's the first principles read. Sand isn't a material. It's a size classification. 0.02 to 2 millimeters in diameter. Within that range, you get terrestrial silica chipped off granite outcrops over millennia. Shell fragments from foraminifera and bivalves. Bits of coral skeleton, volcanic glass from eruptions that happened before anyone was keeping records. The exact composition is determined by what's upstream. Geologically, geographically, Biologically, Hawaiian beaches come in black, green, and white, depending on whether basalt, olivine, or reef calcium carbonate is dominating the input. Some Indo-Pacific beaches are almost entirely foraminiferal. Each grain was once a living organism with an identifiable calcite shell. You're not walking on sand, you're walking on compressed biological history. Desert sand, which a commenter correctly identifies as smoother, has been worked by wind transport into near spheres. Beach and river sand is more jagged. Water tumbling breaks and chips the grains, exposing fresh mineral surfaces. The shape tells you the transport medium, your reading process in geometry. One commenter raises the Fugo story. The Wudu-zi Japanese balloon bombs that carried Pacific sand into the continental U.S. American geologists analyzed the mineral profile and triangulated back to specific coastal deposits in Japan. Sand as forensic instrument, every grain a data point with provenance. A thread comment lands precisely, a peek into the real wonders of the world and not the usual opinionated slop. That's the appetite. People want to be shown something real. No agenda, no frame. Just here is what exists if you look at the right scale. No subscription, no paywall, no gated access. Someone built a thing to show people what sand looks like, and then they let people look at it. Sometimes the interesting engineering question isn't about who controls the system. It's about who thought to point the instrument at something actually worth seeing. Moving on. Make the strongest case against writing your own Gzip decompressor. Here it is. Zebly has been in production for 31 years. It has absorbed decades of edge cases, CVE patches, platform-specific optimizations, and adversarial inputs. The 25,000 lines are not bloat. They are scar tissue. Each one represents something that broke in production somewhere, on someone's machine, in some obscure situation that you will not anticipate. The canonical advice for compression and cryptography is the same. Don't roll your own. The libraries exist. Use them. That argument is correct for every use case except one. Understanding. This is a blog post about someone who wanted to know how Gzip actually works. Not how to call it, not what flags to pass, but the mechanism, the bit-level structure, the deflate format underneath the wrapper. And here's where the counter-argument collapses under its own weight. If use the library is the complete answer, then nobody ever understands what the library does. And you cannot evaluate a system you don't understand. You cannot audit it, reason about its failure modes, or make intelligent decisions about where to apply it. 250 lines of Rust is the answer to a different question than Zebly, and the craft here is worth pausing on. The Gzip format is a thin shell. Magic bytes, a few flags that a hands off immediately to deflate, which is itself two ideas stacked, LZ77 back references. When you see a pattern you've seen before, point back to it instead of repeating it. Combined with Huffman coding, which assigns shorter bit sequences to more frequent symbols. The bit reader alone, pulling least significant bit first within each byte, accumulating a buffer, masking out what you need, is the kind of low-level craft that makes you appreciate every abstraction sitting on top of it. This is quietly shaving bytes off planetary-scale traffic. The browser won't even mention it. It just works, invisibly, constantly. Take the don't reinvent principle to its logical extreme. Applied strictly, it means no one ever reads a compression paper. No one develops the foundation to evaluate whether a new format is genuinely better, or just marketed that way. The principle was meant to prevent production mistakes, not to lock understanding behind library interfaces. A commenter here points out that Plan 9's Gzip is 738 lines total. Legibility and correctness can coexist. Scar tissue is not the same as necessity. 250 lines. Read it. you will understand something you didn't before. Who owns the code you run? Pause. And who owns the account you need to run it? What does it mean when the most consequential fight at a technology company isn't about what to build? It's about what to stop forcing on people. Microsoft's Windows 11 requires an internet connection and a Microsoft account to complete setup. This is not a technical constraint. The engineers who built Windows know how to boot an operating system without phoning home. The requirement exists because multiple internal teams benefit from it. Telemetry collection, account funnel, OneDrive uptake, edge sign-ins, subscription surface area. It is a policy decision wearing the clothes of a setup screen. Saad Hanslam, VP and long-standing developer advocate, responded to a user inquiry on X with 3 words. Yeah, I hate that. Reportedly, he's not alone. There are people inside Microsoft actively pushing to relax or remove the requirement entirely. Here's the devil's advocate position. Maybe forced accounts are defensible. Sync settings, automatic sign-in to Office, OneDrive backup on by default. These are genuinely useful features. The article author admits they prefer having them. And there's a real security argument. Linked accounts enable account recovery flows. Remote wipe, better telemetry for catching malware patterns at scale. A case exists. That case collapses at the word forced. Every benefit of a Microsoft account remains available when the account is optional. The sync works. The recovery works. What changes when you remove the mandate is that users without reliable internet, users setting up machines for elderly relatives, users who simply want to run a local OS on hardware they own, they can complete a basic task without being blocked at an authentication gate. The functionality doesn't diminish. The funnel does. One commenter frames it precisely. This is more political than technological, a fight between the Windows team and the divisions that treat the OS as a marketing channel. That's why the fix requires a committee rather than a pull request. Hanselman has the credibility and apparently the internal will. What he's up against is captured attention that multiple teams have built roadmaps around. The technical path is straightforward. The organizational path is the hard one. Microsoft's own engineers have already diagnosed both. An operating system that requires the manufacturer's permission to set up locally is worth a direct question, not a rhetorical one, an actual one. Who is this for? This has been your daily tech feed for Hacker News for March 27, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go look one layer deeper than you normally would. We'll see you back here tomorrow.